What difference does it make whether they have to go straight to the algebra or whether they think about cases first? Might be in different places. Okay, so go ahead and just share with your group right now. Okay, is everybody kind of on the same page with what they're coming up with? How do you think your kids would work through this problem? Is 84 a number that they need what am I about to say? They're going to need a calculator for this? Okay.
Sadly, yes. Sadly, yes.
Sadly, yes. Is there a reason for us to go either way on that question of calculator? So they use a calculator for multiplying by 10. And do we want to do something about that?
This is like an open-ended question because the problem doesn't tell us how many points.
Right, but it says he only has dimes and pennies.
Yes.
But only dimes and pennies, but it doesn't tell us how many 10 points.
Right,
And then like if we have a,
but it tells us
It
what
tells us the amount, it doesn't tell us how many. Yeah, for a system of equations.
So you could end up writing this out as a two-variable equation, right?
So it's like an open.
But is there ever more than one answer for each of those pieces? Talk with your group and see if you can prove that to them. Okay. What? Reason was multiplying by 10 and calculator.
I don't like it.
It's nice. It's 36. So
The whole thing is great. Okay, the question
It's a regular linear equation.
yeah, it's a regular linear thing. So how would you use
How would you want it?
No, I want to know how would you use this equation. System of equation. Right, two variables, but one is different. I'll give my son as a warm up and see how different things. Yeah.
At senior level, you're okay?
As you know, this is not one of them.
I'll give my son tomorrow as a warm up.
In those kind of regions, you don't know how much is
What they've been doing.
Okay.
The only thing is the last one.
I think it'd be interesting. Like, this is definitely something that we use to manipulate language because of the time that you can count. This is why it is intensive.
Okay, so how do your kids do on this problem? So first of all, one of the catches in this is, can we strengthen our students so that if they get this problem without these cases to consider, that they can still do it for the general case, right? That's our challenge, right? How do we build in kind of utilizing this as a method for them? How do we do that, right? Okay, so if we're writing the problem, we can write it in, we can scaffold it. But when they're sitting there alone on the test and it's figure out, find the expression, that might be something that we'd see on a multiple choice test, right? That is a relationship between the number of pennies and the number of dimes, okay? So how might your kids work through this problem? What do you think? Yeah.
You just start with the number, then what operation, and what's the result. Number.
Give me an example. So number.
So you would say number of dimes. That would be one column.
Okay.
So you put 3. Now
dimes.
what do you do? I say 10 times 3, so I multiply the dimes by 10, and then I subtract that from 84, and I get the number of pennies. I get 54. So they say 84 minus 10D. And then they do that the next time, and the next time, and the next time. Then they can see the pattern of 84 minus 10D developing for D dimes.
Okay,
So what do they have to do to get to the pennies? What do they have to do to get to the pennies?
so one thing I'll also kind of put out as a strategy is, okay, so they put in 3, I think you said, and this is the column for the number of dimes, right?
Right.
Number of dimes. Okay? So what are they going to write next? And is that what we want to write? What are they going to write again next?
Well, they're going to figure out whatever prior knowledge they have. They're going to say, I know 3 dimes is 30 cents.
Okay. Huh?
And then they're going to subtract that from 84 and come up with 54 cents.
Okay. So let's think about how this is what they're going to do. They're going to say 3 dimes. Okay, that's 30 cents. They might reread the problem and say, okay, so now the rest of it has to all be pennies, right? And so they might do some things. Now, we had a little conversation about calculators. Are your kids going to use a calculator from here to here? Some might, because they forgot that they do know that answer. Because it's just a physical habit. And actually they knew that. They actually still do have that as a mental math skill. Okay? So as their teachers, it's like, okay, am I going to deal with a tussle over this? Are there certain days of the week or where we start out with no calculators and we don't bring them out unless they don't get to use them on Mondays, Wednesdays, and Fridays unless we say, okay, you can take out a calculator, right? What's our process, okay? So they eventually have to, what are they going to do? Are they going to do 84 minus 30?
No, they will add. I'm sure they're going to do the value of dime plus the value of pennies.
So this is interesting, right? Are they going to kind of think about, well, maybe they'll think 30 plus what is going to give me 84, right? And that's fine, right? But, or they might even not, they won't write it out though, will they? They're going to do it as mental, right? So we might see something like, I mean, they're just going to write 54. Is that what they're going to write next? And they may not show us what it was, right? So let's see what their table might look. Oops. The next one is a 7 and then a 4. Okay, so 7, they might write 70 cents. They might do a little thinking and figure out that that's 14. 4 dimes, they might say 40 cents. Do a little something. Who knows? They might have made a mistake somewhere in the several calculations that just took place there, right? Does this really tell them the algebra when they put in D dimes? Okay. It depends. It doesn't. It's not calling out though. Quite. Okay. So, isn't that what you do when you don't have your eraser handy? Yeah, whatever. Okay, so I'm gonna just, we actually might have talked about this last month, But I use a phrase called indicated arithmetic, and I push that, right? I say, you know what, I want you to show me how you got that. And they're a little annoyed with me when I say this. It's like, I just know, right? That's what they want to say. But if I push them hard enough, or if I show you, sometimes if I show them what we're talking about, right? What was the arithmetic that got you here, right? Because, okay, miss. That's what they might say, whatever, okay? So, indicating the arithmetic. Okay, indicating the arithmetic. You know, I still use that term because this guy passed away not too long ago. Nicholas Branca, he was a math educator in San Diego. You know, kind of used this language with me when I was working as a math coach, and I really liked being specific about that because I knew that when I was working on a hard math problem, this was a helpful process. Okay, it was something that I was sometimes doing. But putting a name on it and being able to talk about it with my students made it a little more specific, right? Because now is it a little clearer as to what the student writes here, right? Does it let the kids see that? So this little tool of indicated arithmetic can kind of be a useful tool. Now, a more current curriculum that we are stealing from at present is from EDC out in Boston, and they call it delayed evaluation. Just as a note, we can kind of understand that, right? So I'll probably just put both of those terms out on a regular basis, right? Delay actually evaluating it and put out the actual arithmetic that you're doing, okay? So this is kind of just a habit. It gets pushed a lot in this chunk, in chunks 2 and 3, okay, about how do we get kids to figure out what really goes here, right? What would be the indicated arithmetic for the next step? I think you're right that their natural might have been to think about what would I add. So I might be writing still 310 plus, I could just put an empty box for a minute, right? To put that there and to try to kind of see, we could still have that conversation about how to figure out what goes there. Yeah?
CPM, like the college preparatory math, has a really good,
Get some check tables?
the 5D process, that, like, you know, basically the same thing. I mean,
Yep.
it sets it as a
Yep.
very good, like, graphic organizer for it, like, set it up to, throughout this, you know, for them to naturally lead
Right.
to algebra.
So college preparatory math is another curriculum out there, and they spend a lot of time developing the skill of what they call guess and check tables, exactly for the purpose of getting them into this, right? Absolutely. So it is a nice example. Do you guys use that curriculum a little bit, right? It can be a reading intensive curriculum, which, you know, but that's valuable. There's good reason that it is a reading intensive curriculum.
All, you know,
It's
maybe
all
problems.
words.
It's all word problems. I mean,
There's a few.
the homework questions are only times you'll see non-word problems. Never in
Right.
during the lesson.
But absolutely, this kind of idea of really how do you utilize guess and check, guessing tables to really extract the mathematics of a problem, okay? Okay, Andrew, can we go to the next one? Okay, here's another problem. Can you guys see this clearly enough? Actually, okay, so go ahead and start playing with these problems, okay? Some kind of picture problems to think through. This happens to be on page 402, by the way, okay? Actually, a bigger size of it. No, it's right here, 421. So page 421, Page 421 has another version of this exact set, okay? Page 421.
Like when you look at E, where you imply multiplication.
If three triangles, I'm sorry, if three diamonds are 15, what would it? No, it wouldn't be. It's really just kind of think about these objects and think maybe about